Hey everybody, this is Mr. Lowry here. We got this Simplifying Radical Expressions Part 1 assignment, so let's jump in and take a look. The first four problems are kind of like combining like terms. Very similar idea. A lot of times with radicals, which is something that has a root, you get irrational numbers. So for this, let's take this for example, the square root of 3. If you grab your calculator and you find the square root button, right, square root of 3, and you do it, it just gives you square root of 3. So you're like, well, I want a decimal approximation. So you use this key right here, and it changes it to a decimal. But this is actually not 100% accurate. I mean, it's accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. But this number, square root of 3, is actually a decimal that never repeats and that never terminates. So this is just your calculator's best approximation of that number. That number's pretty gross. So what we do when we see square root of 3 oftentimes is we say, look, as long as it's simplified as much as possible, we're just going to leave it. We're just going to leave square root of 3's floating around, and that's okay. So this square root of 3 and this 2 times square root of 3 and this 2 times square root of 3, they're all what we call irrational numbers. And with irrational numbers, a lot of times we can just kind of treat them like variables. So think about this. Here's a square root of 3, here's a square root of 3, here's a square root of 3. Imagine if these were called x's, right? Like, imagine if we said x was equal to the square root of 3. So I have negative x minus 2x plus 2x. Would you be able to combine them? Sure. You'd say, okay, the negative 2 and the positive 2, they're additive inverses, so those just add to give me a 0. So I have a negative 1x left, and that's what you'd say your answer is. But in this case, x was equal to the square root of 3. So really what I have is the negative square root of 3. Now you actually don't have to like write that out or make that substitution, but what you can do is just say, look, this is all the same thing. These square roots of 3, they're all the same value. And I have negative 1 of them, and I have negative 2 of them, and I have positive 2 of them. And so if I put those coefficients together, the negative 1, the negative 2, and the positive 2, I get negative 1. So I just have negative 1 of these guys left over. And that's kind of all there is to it. So what we're looking for is we want the root, or the radical expression, to have the same index number. Index number is the number, like the root number. In this case, when we don't see the root number, we know that's an invisible 2. This is a square root or a second root. Okay? And we also want to have the same number inside the root. That number is called the radicand. So we want the same index number and the same radicand. And if that's the same, then we can kind of treat them like terms, and we can put them together. Okay? Now, number 2, notice that these actually aren't the same. So we can't combine them yet, but we can try to simplify them. So one of the things that we talked about kind of down here is how we simplify a radical. And one of the ways we can do that is we can factor. So let's just take this guy for a minute, 2 root 18. Now remember, that's 2 times the square root of 18. Okay, so just remember that there's a 2 out there multiplying it. But let's talk about the 18 by itself. If I were to factor this, I can factor it to 9 and 2, or 6 and 3, or whatever. What we're making is called a factor tree. And we just keep breaking the numbers down until we have all what we call prime numbers, or numbers that can't be divided anymore without getting fractions. So 18 is a 2 times a 3 times a 3. So square root of 18 is the square root of 3 times 3 times 2. Okay, or in other words, you can say it's the square root of 3 squared times 2. Right? And since the square root and the square undo each other, this part you could actually you can break up. This is the square root of 3 squared times the square root of 2. And this part right here is just a regular old 3. The square and the square root are inverses, they undo each other. So what happens here is I get a regular 3 multiplying a square root of 2. So that's actually what the square root of 18 is. The square root of 18 is 3 times the square root of 2. That's the simplified version. But remember up here we had a 2 multiplying it. So this is actually, right here, this is a 2 times a 3 times the square root of 2. So altogether that's going to be 6 times the square root of 2. And now you'll notice that we do have actually like radicals. So the first step we want to do here is actually simplify all of the radicals as much as possible to see if we actually do have like radicals, or kind of like terms. okay? Here we have something similar, so let's factor 8. Okay, so 8 is 4 and 2, which is 2 and 2 and 2. Okay, so the square root of 8 is equal to the square root of 2 squared times 2, right? So that's a 4 and that's a 2. 4 times 2. I can take the square root of the 2 squared part. The square and the square root undo each other. So I just get a 2 left over, and then I have a square root of 2. So that's actually what 8 is. It's 2 times the square root of 2. Right. But since I have a negative 3 in the front, it's negative 3 times 2 times square root of 2. Or negative 6 times the square root of 2. Okay. So when we simplify those, this is what we end up with. We actually have negative 6 times root 2 plus 6 times root 2 minus 2 times root 2. So if these all have the same index number, which they do, and they all have the same radicand, which they do, then we can treat them like variables and kind of combine like terms here. So like let's just think of them like x's. If I have negative 6x and 6x and negative 2x, when you put all those x's together, you just have negative 2 left over. And the square root of 2 is the thing that you, like the variable, basically. All right, so that's kind of how to manage that one. Let's do a couple more with the third roots. Okay, now third root is the inverse of the third power. So when we're simplifying something like 54, for example, we're looking for powers of 3. So if I take 54 and I factor it, I know 54 is 9 times 6, and 9 is 3 times 3, and those are prime, and 6 is 3 times 2. So notice there's the power of 3, 3 times 3 times 3. So the cube root of 54 is equal to the cube root of 3 cubed, or 27, times 2. And these guys will undo each other. So if I have the cube root of 3 to the third, and I have the cube root of 2, this guy I can't do anything with. But this guy, these 3's cancel, and I end up with just a regular 3 outside. So I have a negative 3 times the third root of 2, that's that guy. And then this next piece here, remember this is going to be 3 times the third root of 2, but there's already a 3 out in front. And so those 3's, like just the cube root of 54 by itself is 3 times the cube root of 2. If I multiply that by another 3, then I'm going to have 9 times the cube root of 2. And then I'm going to subtract 2 times the cube root of 3. Well, these guys right here are kind of the like radicals, but this one's not because it doesn't have the same radicand. There's a 3 in there instead of a 2. So these ones we can combine if we have, think of these as like x's and this is like a y. Right? These ones I can combine because it's the same radicand and the same index number. So the negative 3 and the 9 combine to give me a 6, and it's the third root of 2. And I have minus 2, third root of 3. And that's as far as I can go because these are not like radicals. All right, so I'm going to leave you 4 to try. You're going to have to simplify this guy first to see what you got there. Just as a hint, you could do 8 and 3 here, or 2 and 2 and 2 and 3. So there's a 2 to the third power inside 24. So you can kind of simplify that. Remember, whenever you simplify, this number out front has to multiply whatever number comes out front, and then you can combine the like radicals. Okay, so a little bit of simplifying going on first, and then you can come back and go from there. All right, now what we did in the previous problems here is what we're going to do here. We just have bigger numbers to work with. So what we're practicing is we're practicing looking for factors. Now, of course, you can, like, it's possible to use a calculator on these, but it's better if you get used to doing it without a calculator because it'll help you understand like factors better and help you to see factors better. So that's, you could take the square root of 180 and put it in your calculator. It could give you a simplified version, but you're not really learning anything about roots. You're not really learning how to factor. You're not really practicing. So in this case, I asked you to make a factor tree so that I can see your factor tree and then use those factors in order to simplify. Okay, so when you make a factor tree, it doesn't really matter which numbers you start with. Like 18 and 10 would work here, but also like 20 and 9 would work here, but also like 90 and 2 would work here. So it doesn't really matter what you pick. You could put 5. I'm just going to go 18 and 10. It's all going to come out the same anyway, because we're just going to keep breaking it down. So 10 is 5 and 2, and those are both prime numbers. Okay, 18 is 6 and 3. 3 is prime, and then 6 is 2 and 3. Okay, so let's kind of group them together and see what I got. I got a 2 and a 2 and a 3 and a 3 and a 5. So if I were to rewrite this, I can rewrite this as 2 times 2 times 3 times 3 times 5. Now remember, we're looking for squares. That's the whole idea. This is a square root. It undoes the power of 2. So we want as many powers of 2 as I can. So like 2 squared, right? 2 times 2. I got 3 squared, which is 3 times 3, and I got 5. Okay. And if you want to break this up, this is one of the properties we talked about. We can break this into 3 separate radicals. Each factor is now a radicand. And the square and the square root in this case undo each other. That 2 and this invisible 2 out here undo each other, and we just get the 2 inside. Same thing happens here. This invisible 2 and this power of 2 undo each other, and that's just a 3. And nothing can really happen here. This is just root 5. So that just kind of stays stuck. These guys give you a 6. So you have a 6 multiplying a root 5. And that's how that one works. So make that factor tree so I can see the factors, and then the property of radicals that we're using is that this goes to this. This is a property of radicals. If you have a bunch of factors under a root, you can break that root up into a product of those 3 factors with a root on each one. So that's what we're doing there. All right, let's take a look at number 7. Okay, so again, I have 112. Now, if you need a calculator to divide 112, that's probably okay. I just don't want you to type in 112 and be like, oh, this is the answer, right? Have the calculator do all the work for you. But I know it's divisible by 2 because it ends in a 2, or it ends in an even number. So if I wanted to break that down, that's cool. And then if you're like, okay, I don't know what 112 divided by 2 is, you can do that. So it's 56, okay? And 56 is, let's see, 7 times 8, right? So 7, there's a 7 in there, and an 8 in there. And then 8 is 4 times 2, and 4 is 2 times 2. Okay, so 112 is actually equal to 2 times 2 times 2 times 2 times 7, or 2 to the 4th times 7. I'm just going to double check that here. It looks good. So when I take the square root of 112, it's the square root of 2 to the 4th times 7. Now remember, the idea here is that we're looking for powers of 2. Powers of 2 are undone by this square root. So I could rewrite this as 2 squared times 2 squared times 7. So now I have those squares, right? I just split 2 to the 4th up into 2 to the 2 and 2 to the 2. So I can take the square root of each one of those factors individually so that the 2 power of 2 and the square root undo each other. So this is a regular 2 out front, this is a regular 2, and this is a root 7, and they're all getting multiplied. Or in other words, we got 4 root 7. 2 times 2 times 7. Now, another thing you could have done here is if you knew, like, oh, yeah, 7 goes into that, or 16 goes into that, or something, you could have said, oh, it's the square root of 16 times the square root of 7. And you can say, oh, the square root of 16 is 4, so it's 4 root 7, right? So, like, when you're factoring down here, I asked you on this to prime factor them, but sometimes if you can recognize the bigger powers, like the bigger perfect squares inside of it, you can go faster. Like if you're like, oh, that's 16 times 7, and you knew that, and you knew 16 was a perfect square, you could kind of go right from here to here. But I think breaking it down into pieces will actually help you to see that. Oh yeah, 2 times 2 times 2 times 2. That is 16. Okay, so 16 does go into that. You can kind of see it that way. Either way, you're going to get 4 root 7. Okay. So if you run out of room, or if you feel like you need more room, you're welcome, always welcome to do this on a separate sheet of paper. I just need it to be organized. I need to see, kind of a flow. of reasoning here. So I know this isn't perfect, but you got like my factor chart, and you're like, I break it down, break it down, break it down, and then put my final answer. So I'm kind of going like this. So there's kind of a logical flow there. Let's keep going. Let's do one of these other powers, okay? Let's take a look at let's do 12 since we've been doing some of the odds here. All right, so first thing I would do is I would factor this guy, okay? So 25 and 10 will work. It's not the only way to go, but it's one way. All right, and let's keep going. 10 is 5 and 2, 25 is 5 and 5. So those are your prime factors. So 250 is 5 to the third power, 1, 2, 3, times 2. Or, in other words, it's like 125 times 2. Okay, so now what I can do is I can take my root, and I can say that the third root of 250 is the third root of 5 to the third times 2. Now, if you're kind of getting the hang of this, you maybe are starting to realize like that these are going to cancel right now, but you're still going to have the 2 inside the square root, or the third root. And so if you want to jump just to the last step from here, I'd be okay with that. But let me just write it out for those of you guys who need it. So the third root of 5 to the third times the third root of 2. Just using that property of radicals that says if I have a product inside the radical, I can write that as the product of 2 radicals. Okay, so I have a third root of 5 to the third and a third root of 2. But this 3 root and this 3 power undo each other, and I just get a 5. All right, that's what we got left. All right, so let's do number 10 because that's a 4th power. So when you have a root, excuse me, it's a 4th root. When you have a third root, you're looking for third powers. A third root cancels third powers. When you have a square root, you're looking for powers of 2. The square root cancels powers of 2. A 4th root cancels powers of 4. And so what we need to do is we need to find powers of 4. So let's start out by seeing like what divides 243. So again, for this part, you could probably use a calculator, and I'd be okay with that. But not to like do the whole problem for you, just to help you with the factoring. Okay, so 243 turns out is 3 times 81. And 81 is 9 times 9. And then each of those 9s is a 3 times 3. Sorry, it's getting a little crowded here. So what I have is 3 times 3 times 3 times 3 times 3. Sorry, it's a little bit messy there. So that's 3 to the 5th power. So this is the 4th root of 3 to the 5th power. Okay. Now, again, what we want is we want powers of 4, not powers of 5. This 4 will undo powers of 4. And so what we're going to do is we're going to rewrite this as 3 to the 4th times 3 to the 1. We're just going to factor or split up or break up that 3 to the 5th power. Okay, so this is actually 81 times 3, the 81 times 3 you saw over here. And it turns out that the 4th root of 81 is 3. We can see that when we do this, the 4th root of 3 to the 4th times the 4th root of 3. This is 3 to the 1. Okay, now this 4 and this 4 will undo each other, and we just get that 3 out. This we can't do anything with, we just got to leave it. Okay, we don't really need the power of 1 in there either. So if this power is bigger than this index, then you're going to get some stuff coming out. You're like, yeah, there's definitely 4 3s in there. I can take the square root of 3 to the 4th power. Excuse me, I can take the 4th root of 3 to the 4th power. I'm just going to have a leftover 3 inside. All right, let's take a look at the back here. Okay, the back is really, really similar. It just has variables. So when you break it up, you just kind of break it up the same way. The number part, you start with kind of the prime factoring, and you go from there. So I think I'm going to wait to do this in a separate video, just so we have, kind of break up the video. And so tune into the next one. We'll talk about the same kind of idea, but with variables.